In the United States, food waste is estimated at between 30 to 40% of the food supply. Every day, millions of people send tons of food to landfills to rot. So, what's the solution? Well, it turns out it might be right beneath your feet. Studies from Cornell University state that between 3 and 6% of agricultural soil is composed of organic matter.
Composting can take this ice cream and turn it into this plant.
As you can see here, the life cycle of compost starts with our food scraps, which then we throw into the compost bin. Then we have to wait for a good while the germs and the bacteria and other organisms break down the food waste to turn back into soil, and then we can use that soil to grow more fruits and vegetables.
Soil that contains organic compost is known to prevent soil erosion, assist in flood management, boost plant growth, conserve moisture, and even collect carbon from the atmosphere, reducing the effects of climate change.
In nature, everything is recycled, but in human society, that's not the case. If we could relearn to be more closely aligned with nature, many of our environmental problems, including food waste, would be solved. Let's take a closer look on the big board.
To understand composting, first we need to understand soil. Soil is divided into 4 layers called horizons. You got the O horizon up at the top, then you have the A horizon, then the B horizon, and finally the C horizon. Most of the organic matter present in soil is at the top layer here. Organic matter is the stuff that plants use to grow. Now, how does that organic matter get there in the first place? Well, let's take a look at that over there. Bacteria are part of a broader soil community, shown here. In the bottom left here, we have bacteria. Then at the top left, we have plants, demonstrated as plant roots. At the top right, we have soil macroinvertebrates. And then at the bottom right, we have fungi. Healthy soil promotes a healthy soil community, and a healthy soil community promotes good quality soil, in kind of like a feedback loop. You might be wondering what these arrows mean. The arrows indicate reliance on other organisms. So bacteria are reliant on fungi, and fungi are reliant on bacteria. Each of these different organisms consumes different things, some of which are produced by the other organisms shown on the diagram here. You can see there are arrows connecting every organism to every other organism. The 2 main nutrients present in soil are nitrogen and phosphorus. Nitrogen, present in the cycle here, and phosphorus, present in the cycle here. Both of these cycles are driven by bacteria. Bacteria, called nitrogen-fixating bacteria, take nitrogen out of the atmosphere. Plants can't use the nitrogen in the atmosphere, so we gotta first turn it into nitrate and nitrite. Those are the forms that plants can use. These nitrogen-fixating bacteria turn it into ammonia, and then other bacteria turn it into nitrate and nitrite. Bacteria have a little bit of a different role in the phosphorus cycle. Phosphorus isn't present in the atmosphere in any large quantity, but it is present in rocks. Those rocks get weathered by events like rain, and that releases HPO4 and H2PO4 into the soil. Plants can use those forms of phosphorus as nutrients, and then when those plants die, bacteria decompose their remains, returning phosphorus to the soil. Now you might be asking yourself, how does any of this relate to composting? Well, composting increases the amount of organic matter in the soil. Organic matter can be transformed by the bacteria into other forms of organic matter that plants can use. You might also be wondering, well, why can't we just use fertilizer for this? I mean, doesn't fertilizer also put organic matter in the soil? The difference is, fertilizer is present only at the top layer of soil, even above the O horizon sometimes, just laying on the top there. Compost, however, is integrated into the rest of the soil, throughout the O and A layers, and even into the B horizon. So, being more integrated into the soil means that it promotes a better soil community, which promotes better soil quality. This is how nature does things. Composting lets us do the same.